Okay, alright. Hello everyone, my name is Markiplier. I'm kidding. Okay, so, I'm gonna be making this quick little thing, just to go over, like, all of the stuff between, the differences between, fdopen, pipe, and dupe2. So, it seems to me that a lot of people are misunderstanding what fdopen actually does, where people are believing that fdopen will open a stream, and they think that this is what creates the actual buffer, right? Am I correct in assuming that?
Yeah, that was my misconception.
Alright, fantastic. So this is actually not what it does. fdopen, so imagine that all of these individual little fuckers are little boxes over here. And all of these have file descriptors. Oh, and by the way, let's make a little table over here. Alright, let's make a little table of file descriptors. And Alright, so the 0th one and the first one, I always get these two mixed up. I forget which one's input and output, but let's just, for the sake of posterity, say that this one, 0 is input, and 1 is output. I am so sorry to anyone that that goes over this and thinks that, and realizes that these two are swapped. If they are, I apologize. Alright, anyways, so this little table of file descriptors, these are going to be the ones that are going to be constantly open, that are going to be like native, right? The standard input, so std in and std out, are going to be the general streams of things that occur. So like imagine that you are like working on your computer over here, and you type something like on the keyboard. So what happens, like say you type something into the console, right? So what happens is you are like making input, and that input is then being sent, and it's going to be buffered. And what that means is basically all of that stuff that you typed and all of that stuff that occurred once you hit enter is being stored up until you like actually want to send it, right? So what occurs during here is this will take all of that buffered input and send it through to standard input. So this is what like we do when we use like fscanf, fgets, etc. Does that make sense?
Yeah.
Cool. So now once that stuff, like this little stream occurs and it exists, that stream, any process can read to it, or can read from standard input, right? So that this stream over here will send that data into our program, and over here we're going to call it program. So now when we receive the standard input through our program, we do whatever we want with that data. Like I don't know, like if the user wants to send us like 3 and 5 in standard input, that gets sent as a string into our program. And say our program just wants to add 2 numbers together, it'll be like, okay, I have been given the text of 3 and 5, I've been given the strings, I'm going to convert those, blah 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 blah. Alright, cool. So now here's the thing about piping that people have been misunderstanding. So piping will create, so what people are currently doing is they're thinking that fdopen is the be-all end-all for creating a brand new file buffer. That's just not true. What creates the new file buffer is going to be pipe. And what pipe will do is it will go into this table over here, and it'll be like, hey, can I like get an input and an output file descriptor just allocated on your stream table real quick? And then the operating system goes like, hey, sure, I'll give you the lowest file descriptor number on my file descriptor table, right? So like imagine that this is process 1. I'm gonna call it P1, this one's P2, and this one's P3. So P1 is going to ask for pipe. It's going to say, hey, can you turn me into a stream, basically. What P1 does is it goes like, hey, I'm going to call pipe. I now want you to turn me, this process myself, into a stream. So what it does is we now have a very special little thing that occurs over here. Yoink, yoink. We're going to make this a little bigger. Womp. All right. And now here's what occurs. So when we call pipe, we now turn this process into a file stream. Does that make sense?
Yep.
Fantastic. So now imagine this over here. This is now like a pseudo new version of standard input and standard output, but it's not actually like it's not the original one. And also it's going to have a completely different file descriptor. However, what it does do is we have an output and an input. And these, by the way, are file descriptors. Like pipe will be like, hey, I'm going to return to you a brand new stream that you are requesting. And that stream has the ability to output data and take in data. Okay? And you can set that to get input or send output from and to anything using doop2, right? So, but we'll get to that in a second. So real quick, what process 1 does when pipe is called is it goes over here. The operating system realizes, hey, you want a new set of streams, so this is what I will do for you. I'm gonna do P1 output, or P1 input, I don't know. What one of these is, oh, wait, hold up. One of these is 0. Let's see, pipe, stdin. Okay, cool, 0 is stdin. Fantastic, okay, cool. I did get that right. Okay, so now P1 has like that P1 input and P1 out. So this is what occurs whenever you ask for a new pipe. So what would happen if pipe 2 asked for it to be turned into a pipe?
Wait, sorry, you're asking me?
Yeah. Hey, I mean, I have no one else that I can.
Yeah, well, if
ask
I had to guess, then it would either allocate to 4 and 5, or it would replace 2 and 3. But I would guess it would
And you are
allocate to
correct.
4 and 5.
You're
Sweet.
correct. So now P2 is created and P2 out. So now here's the problem that people have been facing. So this doesn't do us anything. This doesn't do us any good. How do we make it so that all of these fuckers can send their stuff over into bin sort, right? So because if we treat these as completely separate streams, what occurs is we then fail to be able to, like, say this one had like so each of these has 4 lines of input, or 4 lines of words, right?
Sure.
Or, well, yeah, let's just do that. Each of these has 4 lines of things, and each of these will be treated as a completely new stream. So what happens when you send one full chunk of data to bin sort? Well, it'll only sort this 4, and it'll output whatever, like, only the 4 sorted parts over here. So this was like B, A, C, D. This specific chunk of data would then go to bin sort, and it would be output through standard output as A, B, C, D. But now what happens if we have like and by input I of course mean output, so shift this like 1 down. Okay, so now we want to have process 2 output to bin sort as well, but process 2 has C, D, E, F. So now these 2 chunks of data are being treated as 2 completely separate streams. So now bin sort goes like, okay, I have outputted my stream. I'm going to close that thingy over there, and now I'm going to output a brand new stream. And this over here is C, D, E, F. And you see how these are not like sorted together?
Yep.
Yeah, so this is not what people want. What people want is they want to be able to send all of this data. Like, even though we've achieved, or we've broken up that data into n quote unquote buffers, we want to set, not input, output. Even though we've created n buffers, we want to only like get the standard output of bin sort to be one large thing of A, B, C, D, E, F. And this is what everyone wants, right? So the way to achieve that is by using dupe2. So yeah, so what dupe2 is going to do is basically it will associate a file descriptor with with another file descriptor of your choice. So basically, if you have, we're going to draw this table again. So, and this time we're only going to have one thing. So we're going to have, so I'm going to do regular input, regular output. Now we're going to do process one in, process one out. All right. So, yoink, yoink, yoink. All right, cool. And these are, again, going to be 1, 2, 0, 1, 2, 3. Okay, so now what happens when we just want to send all of our data through one specific stream, such as std out? Well, what we can do is we can call dupe2, and what it, let me actually just make 100% sure that I'm going to give you the right information. Dupe2 in C. Okay, so it takes an old file descriptor. Nope, that's dupe.
That's dupe one, yeah.
Okay, cool. Old file descriptor, new file descriptor. Fantastic. Okay, so this takes two file descriptors. So like source and destination file descriptor. And what occurs is it will basically remap the source file descriptor into the destination file descriptor. Does that make sense?
Yep.
Fantastic. So if we have process one over here, and we have the data of process one over there, what we do is we say, hey, I know that we tell the operating system, hey, so I know that I've like said, you know, that like my file descriptor, like I wanted a brand new file descriptor for like P1 output, but like I also really want to send my data as one concurrent block. Do you think that you could change my 3 into a 1? Or like, can you associate my output with standard output? And what you do is you'd be like dupe2, and you'd be like P1 out. And by the way, this is like, if we had a list of those file descriptors, so like fd list, and this is going to be that list is allocated to like n things, where n is the number of processes. And this is like how many pipes we have, basically. Does that make sense?
Mm-hmm, yeah.
Fantastic. So this n length list is going to contain all of our processes. So like P2 is going to contain all of these. So it's going to contain the file descriptors to the input and the output of these guys. So what we want to do is we now want to associate, so imagine that like std out is this one concurrent stream. So now what we want to do, if this is the out of both of these, we want to make it so that any data that's being written outside, or is being written through our processes, is being acknowledged as the standard output stream. So now, if both of these guys have A, B, C, D, and this one has D, like D, E, F, G, now what do you think is going to be written?
It should be both lists now.
Right, it's going to be both of the lists. So, and this is going to be like that unordered portion. And now, finally, that's bin sort, so bin/sort takes in that data from standard output as its input because it reads from input, and now it'll sort these and treat it as one concurrent block, and it'll be like, all right, sick, I like it cut, G, and it'll be like AB through like F, right? Dot, dot, dot.
Yeah.
And that's exactly what occurs here. So dupe2 is how you associate your stream buffer's output or input with an STD out or an STD in. So that's how you trick the operating system into thinking that your process is like something or is standard input or standard output. So now we get back over here. So now you understand. So you understand how pipe works now, right?
Mm-hmm.
Fantastic. And you understand how dupe2 works now, right?
Yep.
All right. So how? Now here's the thing, though. What ways do you know that you can? We're gonna go down here a little bit. Womp, 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 womp. So what ways do you know that you can take a file descriptor, file desc, and turn that into like written chunks of data, like write data. Hint: you can't, because here's the thing about file descriptors: they don't describe streams; they describe placeholders of those streams, right? The like this over here for like process 1 and process 2. These are basically descriptions of these streams, right? They are how the process or how the operating system locates these streams in this really large table. Make sense?
Yep.
Fantastic. So this is how the operating system recognizes that these streams are, well, streams. And what it does is this one's going to be like the output stream over here, and this one's going to be the output stream over here. Imagine that these have been closed. So file descriptors cannot write. Say it with me. File descriptors cannot write.
File descriptors cannot be written.
Perfect. File descriptors cannot write. File descriptors cannot read. Why? They are not streams.
Very nice.
Not streams. Like, people need to start understanding that these numbers are not streams. You cannot send chunks of data through that number. However, those file descriptors describe a stream. So, how do we now turn from a file descriptor into a stream? Tell me.
Would we use fdopen now?
Perfect.
Is that what we're doing?
Yeah, exactly. So fdopen will open a file descriptor stream. Does that make sense?
Yep.
All right. So that's exactly what this will do. And now remember how we dupe2'd, like duplicated our, or substituted, I guess. I don't really know. I don't know why they call it dupe2, but whatever. Remember how we, like, when we piped these were completely like separate entries in this file descriptor table?
Yes.
Well, now after we have used dupe2, these guys don't exist. Instead, we still only have these, and these fuckers are mapped out to is this the input or output? I'm gonna say it's,
I think output's 1.
Okay, I think, yeah.
Output's 1.
So yeah, output's 1. So now the outputs of these processes are mapped out to standard output. Make sense?
Mm-hmm.
So fdopen of P1 will open the stream over here. So this is how we turn that file descriptor into a stream. It's basically the exact thing the exact same thing as open with a file name. So fname, and using that like writing permission, using that mode, right? So open with the file name and the mode. However, since these like quote unquote they're not actually file buffers, they're stream buffers. Since these stream buffers are not actually files, they are streams. What occurs is we cannot name these guys. We cannot give them a name. So the solution to that is we can only refer to them as their file descriptors. So we then use fdopen to open that file descriptor stream, and then now any output that occurs between any of these processes will now be sent to what?
Should be SD out.
Fantastic. And now all of the data, all of the concurrent chunks of data that are from process 1 and process 2 are now written into std out. And even though they are like, they seem like they are like separate, they are still concurrent chunks of data in standard output. Like it's just written like as generic chunks of data. And since that is and since that is sent to bin sort, whoops. So bin sort takes that as standard input, and then sends this as standard output. So now, this data that was here before has now been read by bin sort. So now that data has been cleared, and now bin sort will do its own output, right? So now bin sort will like have all of that data that's been written, and it'll have it organized. Does that make sense?
Yep.
Fantastic. So after you do that, the only thing you have left to do is just do like another fgats from the from the standard output, and then or standard input now. Yeah, it's gonna be standard input. So now bin sort sends this as its like output. However, we want to read that stuff in our program, so Uniqify. So now we are in our silencer, and I can write. So now we're in our silencer, and now we're gonna read, read until the end of standard input. Make sense?
Mm-hmm.
All right, and that's it. Like that is. Everyone needs to stop getting confused about those two, and I hope that has cleared up everything about them. All right, there you go.
Very nice. Very well said.
Thank you. All right, and now I'm gonna stop that. All right, hope everyone enjoyed that. Goodbye.